Alright, side 2 of our notes here, you'll see that we have a complex number plane. If you look closely, this says 2, 4, 6. Notice there's no I. So this axis right here is your real axis. And this over here is your imaginary axis because it has the I's next to the numbers here. Now when you graph imaginary and real numbers, complex numbers, you treat them exactly like a regular number plane. You go across on the real axis and then up or down on the imaginary, depending on what you need. So for this first example here, it says 5i. We're going to graph 5i. I is on this, what is normally the y-axis. We'll go up 5. So this spot right here is 5i. Now we have 3 minus 4i. 3 is the real part, and the 4i is the imaginary, so we'll go over 3 and then down to 4i. And the last one is negative 2 plus 5i, so we'll go to negative 2 on the real axis and then up 5 on the imaginary. So that's how you graph complex numbers. Now we'll focus on the absolute value part here. The absolute value of a complex number, these bars right here indicate absolute value. If you have a plus bi, then you can just take the number part of it. Remember, I is imaginary, where a and b are still real numbers, and you can square each of them and then square root it, kind of like the Pythagorean theorem. So you have a squared plus b squared. Notice there's no I, it's just the numbers part of it. So in this example, we want to find the absolute value of 5i. Well, there's no a part of it, so we'll just take the square root of 5 squared. Notice it's a positive 5, because originally it's a positive here, so it's a positive here. Well, the square root of 5 squared is 5. Next one, 3 minus 4i. We'll take the square root of 3 squared plus negative 4 squared. The reason we have that negative 4 is because of this negative right here. So 3 squared is 9, and negative 4, that whole thing squared is 16. So 9 plus 16 gives us the square root of 25, which is 5. Next one, C, we have negative 2 plus 5i. Again, we'll take the square root of those numbers squared. So negative 2, that whole thing squared, plus 5 squared. Again, remember there's no I that goes with that, it's just the number 5. Negative 2, that whole thing squared is 4, plus 5 squared, which is 25. Gives me the square root of 29, and that does not simplify, so your answer is just radical 29. And again, those are the absolute values of those imaginary and complex numbers. Alright, now of course we have to learn how to add, subtract, and multiply these numbers. When you're adding and subtracting complex numbers, it's exactly like combining like terms. So in this first example, we have 5 plus 7i plus negative 2 plus 6i. And again, all you're going to do is combine your like terms. So we have 5 and negative 2. Obviously that does not add with the numbers that have i's with them. So 5 and negative 2 make 3. And then the i's here, 7i and 6i, make 13i. So your answer is 3 plus 13i. Simple enough, basically like adding 5 plus 7x and negative 2 plus 6x. It's just that the x's are i's. Alright, we've got another one, 7 minus 3 plus 2i. Now notice this part is in parentheses, so of course that means you have to distribute this negative onto both of those terms there. So we really have 7 minus 3 minus 2i. Again, combine your like terms. 7 minus 3 makes 4 minus 2i. We'll do one more. We have 8 plus 3i minus this quantity 2 plus 4i. Again, we have to distribute that negative, so we have 8 plus 3i minus 2 minus 4i. Again, we'll combine our like terms, so 8 negative 2 make 6, and then 3i and negative 4i make negative 1i, so 6 minus 1i is our final answer. Alright, multiplying complex numbers, same thing. The only difference is when you get an I squared or an I cubed or whatever that is, you have to simplify that. But otherwise, all the rules are the exact same. So let's say we have 5i times negative 4i. Well, 5 times negative 4 is negative 20, and I times I is I squared. Now you have to remember that I squared is the same as negative 1. Remember, I squared is negative 1. So we have negative 20, I squared is negative 1. So negative 20 times negative 1 gives us a positive 20. Let's say we have 2 plus 3i times negative 3 plus 5i. Again, we'll just multiply using the distributive property. So 2 times negative 3, negative 6. 2 times 5i is 10i. 3i times negative 3 is negative 9i. And then 3i times 15i is positive 5i is positive 15i squared. Again, combine your like terms. So you have this negative 6 out here. 10 and negative 9 make a positive 1i plus 15i squared. Again, I squared is equal to negative 1. So we really have 15 times negative 1, which is negative 15. Combined with that negative 6 gives us negative 21 plus I. Negative 21 plus I. Alright, we'll do one more and then move on. We have 6 minus 5i times 4 minus 3i. Again, distribute, so 6 times 4 is 24. 6 times negative 3i is negative 18i. Negative 5i times 4 is negative 20i. And then negative 5i times negative 3i is a positive 15i squared. Combine your like terms. We have 24 out here. Minus 18i minus 20i gives us negative 38i plus 15i squared. Again, remember I squared is equal to negative 1. So we really have 15 times negative 1. So that makes negative 15. And this 24 gives us a total of 9 minus 38i. Alright, example 7, finding complex solutions. Let's say we have this equation 4x squared plus 100 equals 0. Well, we're just going to solve like we normally would. We'll subtract the 100 over, which gives us 4x squared equals negative 100. Divide both sides by 4, so I can get negative 25 over here. Well, that's something that's squared. So to undo that, you just square root it. So that gives us x equals plus or minus the square root of negative 25. Remember to always use your plus or minus signs. Very important whenever we take the square root of stuff. Alright, again, that's a negative 25. So all you have to do is pull out that I. Square root of 25. Well, we know the square root of 25 is 5. So we have x equals plus or minus 5i. Alright, let's do another one. Negative 5x squared minus 150 equals 0. We'll add the 150 over. So negative 5x squared equals 150. Divide both sides by 5. So x squared is negative 30. Again, that's a square, so we're going to take the square root of it, plus or minus the square root of negative 30. Since that's a negative, we can pull out an I. And 30 has no perfect squares in it, so our final answer is plus or minus I radical 30. Alright, last example. We have 8x squared plus 2 equals 0. Subtract the 2 over. So 8x squared is equal to negative 2. Divide by 8. Gives us negative 2 over 8, which simplifies to negative 1 over 4. Now again, same thing, we're going to square root both sides. So x equals plus or minus square root of negative 1 over 4. Again, with that negative, we can take out an I, so we have plus or minus I times the square root of 1 over 4. And you should hopefully remember from your rules of dividing radicals that if I have the radical of this whole fraction 1 over 4, I can split it up into individual parts. So I can have the square root of 1 over the square root of 4. So that is the square root of 1 over the square root of 4. Well, I know that the square root of 1 is just 1, and the square root of 4 is 2. So if we want to rearrange that to make it look a little nicer, x equals plus or minus 1/2 I. And that's your final answer.